Okay, this is going to be a quick little video on repairing the Jazz board. Jazz board is the name of a board that's used in probably more refrigerator freezer units than any other board, and you program it to match your particular refrigerator freezer. If you buy a new one, you've got to enter a code which is printed on the inside of your refrigerator freezer, and then it'll work with that unit. But getting to the point, if you don't want to buy a new replacement board, because they can be quite expensive, the main thing that goes wrong with these over time are going to be these two power relays. The larger one, I believe, is what switches on the heater for the defrost mode. Normally when people have a problem with their refrigerators, it's because they find out that the freezer section is frozen super solid and the refrigerator section is warm, like room temperature. And that happens because the unit needs to defrost. The cooling fins are all blocked up with ice, and so air can't flow up into the refrigerator compartment. And yet down in the freezer compartment where the coils are, everything is icy, icy cold. So basically you can just order the two relays, and I'm going to show you where I picked mine up dirt cheap. Paid $4.40 for one and $5.99 for the other. You don't really need any tools to remove the board from your refrigerator freezer. You can find all kinds of YouTube videos showing how to remove this board, but basically you just snap a light back, a housing comes down once you hit a couple of snaps. This is held in with snaps. You unplug two cables, you're out of there. Once you're out of there though, in order to get these two relays off, you are going to have to be able to desolder, in case of the big one, 6 places there. And in case of this smaller one, you've got 2 there and 2 there that you gotta have to be able to desolder. So if you don't have a solder sucker, which kind of looks like a needle thing, where you can heat it and just suck the solder out, another way to clear those out of there is to heat a pad up real good and then pound that on the surface, and the solder, being a heavy liquid metal, will normally drop and fall away. You can also try using solder wick, which is just a braided copper, to suck the solder away. Some cases, if it's a newer board, you're better off heating each one of the pads that you're going to be working on and putting fresh solder on there, 60-40, and that'll replace the harder solder. It is a low melt solder that doesn't have a lead content to it. You can tell this is an older board because it doesn't have any surface mount components. And this is a board I'm going to put back in my refrigerator freezer. The newer ones you buy are going to have a lot of surface mount resistors, surface mount transistors. The capacitors, the electrolytics will stay the same. These big caps and the big relays stay the same, but be a lot of surface mount for the other stuff. I can't remember if they surface mounted the main computer chip or not. At any rate, once you cleared all those holes out and removed the old relays, you just put the new ones in and solder them in. Sometimes you can put a little screwdriver in behind the relay and the board to act like a pry bar, and if you've got a long enough tip on your soldering gun, you could hit 2 at a time and free it that way. Or I usually like rocking them to the side, like put the screwdriver in here, heat this up, tips a little bit, heat those 2 up at the same time, tips a little more, keep going back until those are both lifted, then do it to the other side. If you know you've got the new relays and you're not going to use the old ones, you can also, destruct the relays as long as you don't hurt anything else on the board. If you can get them lifted up a little bit, you can go in with your snips and just snip them out of there. Then you can clean the little bits out of there and solder them all back together. Okay, so just a little bit more helpful information. Let us look at, moving the camera up. Hang on, everybody. For example, this is just off of eBay, and it shows back when I had ordered them, but I ordered that one and that one, and here you can see what they're called out as. You can also find that information on your tops of your relays, but it's kind of hard to read on some of them. Let's zoom in even more on that if possible. So if you were searching for them, you could put in the search term pretty much the number starting with the FH after the word relay there. And then down here, I'd say starting with the G5Q over to the word relay. They are 24 volt coils on the relays, but they're obviously switching here in America 120 volts AC, and a considerable amperage when it comes to the heater and compressors and stuff like that. Okay, what have I got here? Now, if you're looking for the tech sheet, and why would you want the tech sheet? Well, could save you a lot of time. You can, let's zoom in. Basically, if you can go to that website, I'd like to provide a link to it, but every time I click on it now that I've already downloaded the PDF file, it just downloads the PDF file. So I haven't been able to link that. So I'm saying you may want to just freeze frame and copy this and type that into your browser. But once you do, you're going to get a PDF file, and here I have already scaled it up so it'd be easier for the camera to see, and started at the very beginning with the programming modes. You can go through and using the refrigerator up-down temperature button and the freezer up-down temperature button and the door buttons on the door of the thing, you can go through all kinds of tests. You can verify whether the heater's working, whether the heater thermostat for defrost is working, whether the normal thermocouple for telling what temperature is working, your compressor, the blower fan, the duct motor. You can test all of these different things, and this is part of one page. I'm going to scroll on down here so you can see there's more to it, and you can you'd have to freeze frame and read one side and then roll back up and read the other. I think it just goes through all the different service tests, like the damper test, evaporator, freezer, fan test. Make sure your fan is working. Test your thermistor, test your condenser fan, performance adjustment, defrost adjustment. This is something that most people don't know about. This is something that's important. If you're having problems with your refrigerator, freezer not defrosting properly, you might want to try going into the fixed mode. As they're shipped, they're going to be shipped in what's called adaptive mode. And what that means is this chip on here is going to try to keep track of how often the refrigerator door or the freezer door is opened and for how long they're opened. And based on that information, it's going to decide how long of a time your refrigerator freezer needs to be in defrost mode. That hasn't worked out well for me. So I have gone in on this service test number 9, and I've put it into the F mode, which is fixed position. And fixed means it has a 6-hour defrost time. Now you can't set what time it's going to do that. It's going to do it whenever, within a 24-hour period. It's going to spend 6 hours doing defrost. Now that doesn't mean the heater's on for 6 hours, because in line with the heater element, there is a mechanical thermal switch, and once that thermal switch is no longer freezing, it opens up. So even though there's a 6-hour period set aside for defrosting, it would only do that if your unit was really iced up bad. It's just going to heat those coils up to get the ice off of them long enough until that thermal switch opens up, and then it'll stop defrosting. So I've gone to that. They do the adaptive because that's supposedly an energy saver, because it's supposed to be able to guess and compute roughly what would be the optimal amount of time, and so that's going to save you energy. You're not running the heater. But it really comes down to being bullshit, because the heater's not going to run anyway once that little mechanical thermometer switch in there, I'm using the wrong word, once that opens up, heater's going to turn off anyway. So that's something that I have gone in there and changed. But it is a very handy set of functions that you can go through for testing everything. And then if you actually want to take it further, they have the wiring diagrams. And I actually used the wiring diagrams to make sure that when it said my defroster was on, it actually was drawing current. I used a clamp-on meter, and it tells you the color of the wires and in what connector you can find them. And I clamped that on there, then I went up through those test procedures, and I told it to go into defrost mode, because you can do a forced defrost mode, and watched my current meter, make sure that in fact the defrost heater was working, but even more important than that, the defrost mechanical temperature switch, make sure that it was working, because if either one of those is bad, you don't have a defrost mode. They both have to be working in order for that to work. So these schematics, which are going to be hard to see because I've got the pages blown up so big, let's shrink things down. There we go. Will contain, if you are an electrician like myself and you enjoy seeing how things are wired up, this does not give you a schematic for this board. It simply gives you the pinout of things that plug onto the board. And if you want to verify whether switches are working, whether heaters are working, whether motors are working, you can do all that with a simple voltmeter or a clamp-on current meter, and you can verify that all that stuff is in good shape. So, could be useful. You might want to look this up if you're having trouble with your refrigerator, because you can diagnose a lot of problems without even buying anything and figure out whether you do need to buy something or not. So hopefully that was a little bit helpful. Like I say, YouTube is just full of videos showing how to remove this board, and some of the videos go through how to do some of the simple tests that I just talked about. But unfortunately, I found that some of them leave out some of the important information. Main thing is, though, when these boards fail, it's almost always the relays, because they're mechanical and they're little contacts pit, and once they pit, they don't always work. They might work sometimes, they might not work the other time. You're going, well, gee, it works every now and then, but once every month or two, all of a sudden that ices up. You know, it's probably time to replace the relays. If they had designed this board with triacs or double SCRs or something, doing the switching to those high current things, they'd last forever. But I'm thinking that's probably why they don't design them that way. They don't want them to last forever anymore. They want you to buy a new refrigerator or pay a serviceman to come out and put in a new board. If you buy one of these boards through a service type place, you can pay upwards of $200. You buy one of these boards by itself and you do the job, I think you're in the $50, $60 range, something like that. Normally these boards, this edge and this edge are combined when you buy them, and you have to snap them free and bend them around this way. They're made as one board for shipping purposes. It makes it a flat pack. It's cheaper just to buy the relays, replace them. If that doesn't fix it, what have you wasted? 10, maybe 12 bucks, a little bit of your time. If it doesn't fix it, then you can go ahead and order a board and slap the whole board in there.